Have you ever wondered how ice skaters or dancers are able to spin so quickly? Well, there is a science behind the phenomena. In this experiment, we will observe our dancer, Amanda Egan, and pinpoint the physics behind the rotation.
The materials we used for our experiment were a spinning platform, a stopwatch, two 1 kilogram weights, and masking tape. We labeled pieces of masking tape to mark specific points on the rotation, mimicking the key points of a unit circle. Amanda stood on the spinning platform to act as our point of reference. We used the stopwatch to measure the time of rotational motion and the kilogram weights as a variable testing moment of inertia.
First, we tested Amanda with her arms out, holding no weights, to find angular velocity. Rachel measured the cycles of her spin to be 470 degrees, while Sarah clocked a time of 6.96 seconds. The angular velocity found, using the formula angular velocity equals rotations divided by time, to be 67.5 degrees per second.
Next, we tested Amanda spinning first with her arms out, then bringing her arms in after one spin, or 360 degrees. We started recording the data after she brought her arms in. The cycles found were 1,110 degrees at a time of 12.61 seconds. The angular velocity found was 80 degrees per second.
Now we wanted to test how weights affect angular velocity. We first tested Amanda with her arms out, holding weights. The cycles recorded was 990 degrees at a time of 5.80 seconds. Her angular velocity was 170.7 degrees per second.
Finally, we measured Amanda's angular velocity with her arms in and holding weights. We followed the same procedure as the last arms in trial, except this one had weights. She spun a total of 1,920 degrees in 7.01 seconds. Her angular velocity was 273.9 degrees per second.
Angular momentum, labeled L, moment of inertia times angular velocity, is conserved. Our demonstration shows conservation of energy. Since the formula for moment of inertia is mass times radius squared, when Amanda brings in her arms, she decreases her radius, thus lowering her moment of inertia. As a result, her angular velocity must increase. Furthermore, with the addition of masses, Amanda's torque increases due to a greater gravitational force. As shown, this makes Amanda spin fastest of all. To conclude, this answers our question as to why dancers and figure skaters can spin so fast.
Tune into our next thing and figure out, oh my god! Tune into our next video to see why this makes Amanda go faster. Oh god.
Don't start timing it yet. Don't start timing it yet.
Now pull your